Hello, welcome back. In this video, I'm going to explain about the Vellum pressure constraint. So by using this constraint, we can fill the air inside the geometry. So first we will take a geometry node, and inside that we'll take an any test geometry. Let's say we'll take a rubber toy. Next, we'll take a node called Vellum configure balloon. So select this. So if you see in this Vellum cloth, now the constraint type is like cloth. So because we want to create a pressure inside the bodies, it has to be a cloth constraint. And also in Vellum pressure, now the constraint type is pressure, so that it will fill the air inside the geometry. And now in order to simulate, we need to add an Vellum solver. So first we'll connect this here. And after that, we'll take an Vellum solver and just connect these three options. And now we want to create the collision to the ground here. So just we'll go to the Vellum solver and we will enable this ground position. And also just we will change the position of this ground plane. So just after enabling this, so just I will decrease the value to minus 0.6 and just will hit play. So see, now it has been created some sort of pressure inside this geometry. And in case if you want to create the stiffness of this geometry, then we can select this constraint. And here you can see there is an option like stiffness. Suppose if I increase the value to higher, so just we'll simulate this. So see here, we got the more stiffness when compared to the previous value. And also when we simulate, now the mesh is distorting. So we need to fix this. So for that, we need to take a remesh node. After the test geometry, we need to take a remesh and just I will decrease the target size. Let's say 0.3 or something. And now we will simulate this. So just we'll go to the Vellum solver. Again, I will play. And now the mesh is not distorting. So we'll change the stiffness value to default. So if we select this Vellum pressure and just I will put it like default. And now next, if you want to increase the pressure in this inside geometry, so if you select this Vellum pressure node, and here you can see there is an option like rest length scale. So if you want to increase the pressure inside this, so we need to increase the value of this rest length scale. So for example, if I put it to like 2, so let's say we will play. And say starting, it is increasing the pressure inside the geometry. So if you play, see now it has been increased the pressure inside the geometry. And also now see some of the pieces are coming out of from this geometry. We need to fix this. So in order to fix this, we need to convert this model into VDB. So for example, if I drag this and just we need to take a node called VDB from polygon node. So just we need to select this and just will decrease the voxel size inside this. So if I select this, so just we'll place a value to 0.02. And again, we need to convert it back to the polygons here. So for that, we need to take a node called convert VDB. So just select this and we need to connect inside this. And inside this, we need to select the option to polygons. So here there is an option like convert to. So here we have to put it to like polygons and say now it has been converted into polygons. And now we will see this. And now you can see the pieces are not disconnecting from the geometry. And now we'll go to this Vellum pressure here. And now what the thing is, suppose if you want to make an animation for this pressure, for example, let's say I will put the value to default like 1. And now what the thing is, after falling down, I want to increase the pressure inside the geometry. So we have to give the animation for this rest length scale. But the thing is, whenever we give the animation for this, it will not directly work to this Vellum solver. We need to do another process. So for example, see here, I have given the animation for this rest length scale. And now until 31, I have placed a value to 1. And after that, I have increased the value to 3. But still here, when I play this animation, so still it is not increasing the pressure. So we cannot directly make an animation for this in order to increase the pressure inside the geometry. So we need to do another process. So I will show that. So first I will remove all these keyframes. So in order to remove the keyframe, just you can right click and there is an option like delete channels. So that it will remove the animation here. So first we need to go inside this Vellum solver and we need to take one node called Vellum constraint property. So just we need to search for Vellum constraint properties and just we need to connect to this force. So if you select this node here, now you can see there is an options to increase the stiffness. So if you increase, if you use this, we can increase and decrease the stiffness, and we can make animation by using this. But what the thing is, we need to increase the pressure. So suppose if I go outside, and if you select this Vellum pressure, and here there is an option called like output group. First, we need to create a output group so that using this group inside this, we can make an animation. So here in this node, we need to enable this output group. And now we'll rename this. So let's say we'll give the name to like pressure. And now we'll go inside this Vellum solver. And just now we will enable this group here. So in Vellum solver, we have this group. So with the help of this group, we can increase the values. So here we need to select the pressure group here. So which we have created inside this like Vellum pressure here. So just we have to go inside. And here we need to select the group pressure. And now here we have to give the animation for this rest length scale. So we need to enable this. And first we need to set the value. Means like first we'll see where the model is going to hit the ground. So the model is going to hit the ground at like 28 frame. So after this, we need to increase the pressure of this geometry. So what I will do is just until 28, I will put the value to 1. So just I will add a keyframe at 28. So in order to add a keyframe, just Alt left click. And now it has added a keyframe here. So, and now just we'll play. So first I will turn off the simulation. So just we can disable this option. So just I will disable. And let's say like after 4 or 5 frames, then I will put the pressure value to like 3 or something. And again, I will Alt left click. It will increase the keyframe. And now we will simulate again. And now see it has been increased the pressure inside this geometry after 38th frame. And also in the final output, we need to see the shader too, because as we converted this into VDB, so after that it has been removed this shader here. So for example, now see if you select this now we need this shader to be applied of in the final output. So for that, we need to take a node called point deform. So for that, we need to connect this geometry. So just we need to connect here. And now we need to connect this lattice points. That means like pressure. So we need to connect here and just we have to apply the animation. So just we need to connect and just we have to enable this. So see now we got this shader here. So now when we play, so we got this. And also in case if you want to make an animation, like suppose if you want to decrease the pressure inside the geometry, just we can give an animation. Means like if you go to this Vellum solver, and here we can give the value. So after this, let's say if I want to decrease the pressure, so let's say up to 58 frame, again I will put the value to 0. So let's say I will put the value to 0 and just I will Alt left click. So now we will simulate this. And see now it has been increased the pressure, and literally in the final it has been removed total complete pressure from this geometry here. So it's a kind of like explosion. So that's it for this tutorial. See you in the next video.